Hello, Cappuccino. So here I am to try and give you some more help with the vector assessment. I tried making a little model of the Earth. So remember I showed you before, I had my little nesting doll of an Earth here. And what I did is I took it apart and I built a coordinate system on the X, Y, and Z axis inside of here. Okay, so what you can see here is I've got my Z axis going straight up like we traditionally do. And so then that would make this my X axis, and here's my Y axis. Okay, so you can see, well, it's kind of hard to see there. So I'm going to go ahead and switch right away to my dock camera so you can see this better. So where's my dock camera? We're having technical difficulties. There it is. All right, so here's my dock camera. And you can see that I've got my Z axis right here. And then I've drawn my X axis right here, and my Y axis right there. Okay, and it doesn't matter how I rotate it. It's always going to be X, Y, and Z because of the right hand rule, right? So if you put your thumb in the direction of the X axis, your pointer finger in the direction of the Y axis, the Z is going to be your fingers, okay? X, Y, and Z, that's how you do it. All right, so here's my X, here's my Y, and here's my Z. So if I'm on the surface of the Earth, by the way, my Russian nesting doll were made in China. If you're on the surface of the Earth, you could have, say, a point like right here or something like that. And if I wanted to give this coordinates in my X, Y, Z coordinate system, what I can do is I can drop straight down. Okay, I'm going to drop straight down parallel to my Z axis. So if I drop straight down parallel to my Z axis, I'm going to end up hitting my XY plane at a point. So let's say I just hit it right there. Okay, so I dropped down, straight down. I tunneled right down through the Earth. Okay, so I'm here on the surface of the Earth. If I want to find out what my coordinates are, I'm going to have to tunnel straight down, not towards the center, but just straight down, parallel to this Z-axis there in the middle. Okay, so I'm going to be tunneling straight down, parallel to the Z-axis, and I'm going to land here on my XY plane. Then, to get my Y coordinate, I'm going to get my Z-axis out of the way so I can write on this. To get my Y coordinate, it's going to be parallel to the Y-axis. Here's my Y-axis. Here's my X-axis. And then my X coordinate, I'm going to move along the X-axis. Okay, so to follow that back to the surface of the Earth, I'm going to travel out my X-axis. Then I'm going to travel parallel to the Y-axis. And then I'm going to travel parallel to my Z-axis, which remember is straight up. And I'm going to go straight up. I'm tunneling under the surface of the Earth. And then I'm going to pop out. You can't even tell that I've tunneled up. Okay, so I'm tunneling straight up. And then I'm going to pop out on the surface of the Earth. Okay, so you can think of it, you're going to need some underground tunnels in order to follow your coordinates. Okay, so X this way, Y that way, and then straight up so that you pop out on the surface of the Earth. Okay, so what does this have to do with latitude and longitude? So I want to, let me put my pin back in there, put it back in my globe. Okay, I want to compare this to some of the pictures that I gave you in the assessment. So if I go over and let me share my screen of the assessment. Oh, where is the assessment? It is hiding here somewhere. That's not it. Is that it? Here it is. Okay. This is a technological challenge. All right, let's look at this one first. So slide 3. I can see where are my degrees of longitude. These are my degrees of longitude. So notice this gray circle here in the middle. This is like the circle that I just showed you inside of my 3-dimensional model. And the 0 here, the prime meridian, that's 0 degrees, that would be like my x-axis. That would be my x-axis. And then as I rotate counterclockwise, I get 30 degrees, 60 degrees, 90 degrees. So degrees of longitude actually make sense. You're used to seeing them on a 2-dimensional map, but they really are the angle that is being made with the center of the Earth. as you go counterclockwise around the equator. Okay, that's our longitude. Okay, our latitude, on the other hand, is as you go counterclockwise from the equator towards the North Pole. So let me annotate this. If I can get my annotation tools. And if I put, say, the center of the Earth, let's see, maybe it's like around there. There's the center of the Earth. I can draw out to, there's my 0-degree angle at the equator. And then if I draw a line up to the 30-degree latitude, you can see this is where the 30-degree angle is. Okay, and then if I wanted 60 degrees of latitude, I could draw my line from the center of the Earth up to, those are kind of lousy lines, up to the 60 degrees latitude. Notice that's making a 60-degree angle with the center of the Earth and the equator. Makes a 60-degree angle. Okay, so if we know our latitude and our longitude, and we know a little bit about the Earth, we can use all these triangles in here to help us figure out the coordinates of any point on the surface of the Earth. Because let's say there's my city right here. Say it's at 30 degrees latitude, okay, and then some degrees of longitude as well. Oops, I gotta clear my drawings. Okay, so I can turn with my longitude, and then I can turn up with my latitude to get to any point on the surface of the Earth. All right, so back to my three-dimensional model. Okay, so back to my three-dimensional model. So if I have my longitude, if the longitude was 0, I'd be right here. And notice in the picture that we had, I had 0 degrees right here, but it doesn't matter because the Earth rotates all the time, right? That's how we get days and nights. All right, so here's my X, on my x-axis, my longitude is 0. And as I turn this way, my longitude is, maybe that's 30 degrees, something like that. Looks like it's about 30 degrees, maybe a little bit less to get to this point right here. So I could, let me get rid of my z-axis here. I could put a triangle here, and this angle, that angle right there is going to be my degrees of longitude. Longitude is an angle. That's why we measure it in degrees. So if your city is at 30 degrees longitude, it's because you're turning 30 degrees away from 0 degrees longitude, which is the prime meridian, which is in England. Okay. All right. So this angle is your longitude. Okay. Longitude is an angle. And then your latitude would be turning. So you're here. And then your latitude is you're going to rotate up. Okay. So, I almost forgot. So this, my x-axis would be 0 degrees longitude. My x-axis is 0 degrees longitude. So my y-axis, this would be 90 degrees longitude. Okay, that would be my 90 degrees longitude. Okay, but my latitude, that's going in the z direction, right? That is, let me put in my z-axis again. My longitude is I'm going to rotate 0 degrees would be laying flat along this plane made with the equator, and 90 degrees latitude would be pointing straight up at the North Pole. Okay, 0 degrees laying down along the equator, and then it pops up in the z direction to get me, my ultimate would be 90 degrees latitude. Okay, so the most you can have in latitude is 90 degrees, right? 90 degrees latitude. Longitude, of course, after we go to 90, then we can still have 100, 110, 20, 30, 40, all the way to 180 over on this side. Okay, and then we go negative longitudes this way, or we go east and we go west. Okay, so now back to how do we get to our point on the surface of the Earth, right? So I said we're going to tunnel down. So if we're here on the surface, we're going to tunnel straight down. Bam, we end up here. And then we're going to tunnel parallel to the y, and we're going to tunnel parallel to the x. So my coordinates, my three-dimensional coordinates for a position on the surface of the Earth is going to have an x coordinate from this distance, a y coordinate from this distance, and then a z coordinate from the one that goes straight up and pops out onto the surface of the Earth. Okay, so I made some little triangles here to help us. So here is this little triangle, okay? So here's my X and here's my Y. And of course, this is a right triangle. So right triangle trig, sweet, nothing hard, no hard math going on there, okay? And then what about the other? How about if I want to pop up? How am I going to pop up? If I pop up, I'm going to have some point up here, and I can connect that point. So here I am up at this point. I can connect that back down to the center of the earth. And this is really hard to see, 3 dimensions. So let me tilt it. If I connect that dot back to the center of the earth, what do I have? Oh, it's a triangle. It's another triangle. So I have the triangle that's flat on the XY plane, but then I have this triangle that's popping up. Okay. And this is my Z coordinate right here, this edge. Okay. So let me lay it down so you can see it. This edge is popping straight up. That is going to be my Z coordinate. So we have X, Y, and then popping straight up. And I'm using this triangle to show how I'm popping straight up. Popping straight up, there is my Z. Okay, so look at that. Look at these 2 triangles. Let me separate them from the earth there so you can see them better. Okay, so here they are laying down next to each other. So X coordinate, Y coordinate, and then remember this one pops straight up. And that gets me my Z coordinate. But I can lay them down, and I want you to notice a very important relationship between them. Okay, what do you notice? All right, so I want to take you back to the picture that was supplied in the assignment. Okay, so if we look at, where is it? Slide 15. These you can see right here. See how they give you phi? I think that's phi, 5, I don't know, whatever. That one is your longitude. See, it says it right here. That's your degrees longitude. Okay, so like I said, this is your degrees longitude. Oh, sorry, you can't see my dot camera at the same time. There's my degrees longitude. My degrees longitude, okay, that's the phi. And then it says theta is the latitude. So those are the ones that are popping up. Okay, so that picture here on slide 15 is what I was basically just showing you in video live 3 dimensions, and how I took those 2 triangles that are in there. Okay, so you notice the 2 triangles, the one that is flat and then the one that's next to it. Let me annotate them real quick, try and help you see them better, because I know this is really hard to see these 3-dimensional images. So there's a triangle right here. There's one triangle, and then the other triangle. Okay, and that one has, before I go on to the other triangle, this angle right here, that's my degrees of longitude. Okay, that's my phi right there, degrees longitude. And then the other triangle is over here. Boom, boom, boom. Okay, and it's got its angle right here. That angle, oh my gosh, my annotation is terrible. That is theta, and theta is the latitude, degrees latitude. Okay, so if I go back to my 3-dimensional model again, just show you one more time. Those 2 little triangles that I was just annotating, here they are again. So this is my degrees longitude, okay? And they were using phi for that. And then this is my degrees latitude. And they were using theta for that, okay? So phi and theta. Phi is longitude. So if you look at this, longitude, they were using phi. And for latitude, which I can't put on this plane, right? Because it's popping out of the plane. It's that angle that pops up, okay? It's popping up, but if I flatten this out, then you can see it. There's my theta, okay? So let me give you a side view of that, okay? So if I take this center plane and I give you a side view, see, there it is. Whoops, my thumb is on it. How can I hold this so you can actually see everything? That's why I need to learn how to animate in 3 dimensions, okay? There is that theta. That theta is my degrees of latitude. Bam. All right, that's the best I can do, I think, trying to explain the connection between latitude, longitude, and a three-dimensional coordinate system. Good luck. I hope that helped. Now I got to figure out how can I stop this video.